Good afternoon, class. Today we're going to continue our discussion of square roots that we started the last time on something called complex numbers. Throughout your previous math classes, you would hear teachers talk about real numbers. Well, after this class meeting, you'll be able to define what the heck a real number is. Okay? So, why don't we flip over here to this other second start. Remember how we were simplifying square roots the last time? Like the square root of 100, the square root of 169. Here's a question. No, you know what? I think I'm going to start this with a big red X. I'm going to show a common mistake. The student sees the square root of negative 100. Maybe I shouldn't have put the big red X. Can you all read that? Okay, so square root of negative 100. Here's what sometimes students will say. That X means it's wrong. The square root of negative 100 is not negative 10. Why? Negative 10 times negative 10 would give us what? A positive 100, not a negative number. In general, like the square root of negative 25, that's not negative 5. Negative 5 times negative 5 wouldn't give you a negative 25. Up until now, we would say something like the square root of negative 25 is not a real number. Tim, why don't you punch that into your calculator just to show the error warning that you would get on, there it is. Let's clear out all of that. If we went square root of negative 25, it's not going to say negative 5.
It's giving you an error. It is not a real answer. That's what that means, non-real. For our purposes, a real number is any number that can be labeled on a number line. You've drawn number lines before and labeled numbers on it. The square root of negative 25 cannot be labeled on a number line, so it is not a real number.
In fact, we're going to define, here's the new stuff, new to this class because I haven't mentioned it before, not new to the world of math. It's been around about 500 years or so. The square root of a negative number is an imaginary number. An imaginary number is the square root of a negative number, and the way that we will work with that or denote imaginary numbers is by attaching the letter I to your answer. Since we started off with square root of negative 100, why don't we do that one right now? The square root of negative 100. If you're taking the square root of a negative number, then that's an imaginary number. Because of this red negative, I'm going to put a red I right there. And then I'll just simplify the square root of 100 the way I normally would. The square root of 100 is 10. So the square root of negative 100 is not negative 10, it's 10i.
You'll type the I using the keyboard on your calculator. The toolbar sometimes has an I hot button, but when you're typing in the I's, just use the I from your keyboard.
Now, I'll say this for the first time this semester. When you're typing answers into Pearson MyLab, only use capital letters.
No, never use capital.
Never use capital letters. Only use lowercase letters and never hit a space key. It'll space it correctly. Let's do problem number 1 in the assignment, Tim.
I'm going to define something for you before we go on. The square root of negative 1. The square root of negative 1, that's the formal definition of that lowercase letter I. I is the imaginary unit. The square root of negative 1 we're denoting as an I. So here, Tony. I didn't mean to interrupt you.
I normally start at a different place. That's a good way to start it.
Oh, I'll keep on going, I guess. This is number 1. The square root of negative 64. Oh, good. Okay. So we have the square root of a negative 64.
Now,
Switch it over. I've written the problem.
Theoretically, they can probably, in a moment, do this without any writing, but and just type in the answer. But
Since it's a negative under there, we know we're going to have that imaginary unit I. Well, what about the square root of 64? Is that a perfect square?
8.
Yes, so all we have is an 8 times the imaginary unit I for our final answer.
And that's what I was meaning when I said you can probably, do problem number 1 without a lot of writing. Let me go ahead and, someone's writing this down. There it is.
The square root of 64 is 8. Since the number under there was negative, we attach the imaginary unit. To simplify the square root of a negative number, simplify it as if it were positive, but then stick an I on it. Okay?
So I'll click here, and at that point I'll get all my little toolbars, including an I. I'll just use this I on the keyboard. 8I. So problem number 1, we had a perfect square under that square root. Problem number 2.
That's the square root of negative 80.
Is 80 a perfect square? It's almost a perfect square. 81 is. But I don't think 80 is a perfect square now, is it?
Switch over to my book.
Yeah, but
I haven't lowered it down over there. Remember, we made a brief list of perfect squares. 80 is not a perfect square. This is from last time's notes. Which one is the biggest perfect square that divides evenly into 80?
About 4 goes into it. 4 times 20 would be 80. But I think there's a bigger one. Let's see. Start with 80 and...
It has to be something lower than 80, okay, to go in evenly. It has to be smaller than 80. I think we can tell 64 would only go in one time with the remainder. 49, 36. What about... Let's see. What about 25? I think that 25's not going to do it. 16. I think 16 is it. 80 divided by 16 gives me 5, right? Are there any perfect square factors that would divide evenly into 5? No, so 5 is the number that will be left under the radical.
So I'm going to go ahead and stick the I here, just to get rid of that, so I don't forget to do it. Now think of this 80 as 16 times what? 5? So, I wonder if y'all can tell the colors. There's a purple 16 and a blue 5. And then the purple square root of 16, I'm going to rewrite as purple 4. Now the 5, square root of 5, no perfect square divides into it. We're through with that. But when you have a square root and an I in your answer, the preferred format is to put the I right in front of the square root. So instead of writing 4 square root of 5i, I'm writing 4i square root of 5.
Pearson MyLab would accept 4 times the square root of 5 times I, provided it's clear that the I is not under the radical. The I is not left under a radical. That's why we put that I before the radical, so you can clearly tell that the I is not under it. We come over here, we type in 4i We need the square root hot button. Remember we were using that the last time. We type in our 5.
And if you were going to put the I after that square root instead of in front of it, make sure it's not under that square root key. Okay, make sure you don't put that I under the square root.
Maybe we'll do, okay, let's do another one.
Okay.
Just like, this is still number 2. It's the square root of negative 96. I want to make a point here. The square root of negative 96. Is 96 a perfect square? Wait, switch over. Is 96 a perfect square? No. What's the largest perfect square that divides evenly into 96?
I'm going to start with, here's my thought process, and I'm showing my thought process with the calculator. 64 can't possibly divide evenly into 96. Neither can 49. What about 36? Nope. 25. 16. It's another one that's 16 times 6.
You know what? Here's how I could what I'm going to do. That's like a negative 16 times 6.
Oh, okay.
And we know the square root of 16 is a 4, but since it's negative, what are we going to stick on? An I. And you still have that square root of 6 stuck on there.
Oh, just in case you forgot about the last time. These aren't little exponents there. My brother closes the square root symbol there.
You know, I guess if I'd written it like this, 4 square roots of 6 times I, as long as that I is clearly not underneath that square root, my lab's going to accept it. So
let me show you what I'm talking about. If you punch it in like this, 4 square root of 6, and put the I right there, y'all see the I is under the square root symbol? It's going to say wrong. Okay? What's wrong about it? That I should not be under that square root symbol. It's best to put the I in front. Like,
wait, you know what? You're
I
not making
deleted the I.
You didn't. Here's something I wanted to show. If you use your right arrow, or if you use your mouse and click outside of that square root, I just use the right arrow key. Notice the cursor is no longer underneath that radical. You type your I there, then they're going to accept it. As long as that I is not under the square root symbol. But for our purposes, it is standard practice to put the I in front of the square root. Any questions there? Okay.
Well, the name of this assignment is complex numbers, so let's define what we mean by a complex number before we do problem 3. You want to lift it up, Tim?
Yeah. There. Okay. A complex number is any number that can be written in the form a plus or minus b times I. Notice this thing doesn't have an I attached to it. It's a real number. This thing here has an I attached to it. That's the imaginary number. So a complex number is the sum or difference of a real number with an imaginary number. And the algebra involving complex numbers is amazingly similar to just the algebra of variables. I is like a letter. You can't combine something that doesn't have a variable with something that does have a variable. Just like if you had a 3 plus 4x. Could you combine those two? Are they like terms? No, they cannot be combined. Likewise, 3 plus 4i. You cannot combine those two. Cannot be combined.
They're just what's called a complex number. Complex number has a real number and an imaginary number together.
Here's something that's interesting. You may not think so, but real numbers, every number you've ever seen in your life is itself a complex number. Any real number plus, suppose the coefficient on the I were 0. 0 times anything is still 0. So it's interesting to note that real numbers are also complex numbers.
They're just a small subset of the complex numbers.
That's
right?
correct.
Okay. Now let's see this problem number 3. It looks terrible.
Oh, I think I'm going to go to, I'm a big writer, so do you think you can get it done with that amount?
I probably could, but you can go ahead and write big.
Oh, okay. We have -6 plus the square root of -54, all divided by 3. Okay, switch it. If you see the square root of a negative number, the first thing you're going to do this semester is rewrite it using a letter I. That's -54. Since it's a negative under the square root, we know we're going to have an I there. Is 54 a perfect square? No. Okay, what's the largest number there that divides evenly into 54? It's the only number. 9. So we're going to think of it as, this whole part that I'm writing up here is my thought process. That's the square root of -9 times the square root of 6. How are we going to denote the square root of -9? The square root of 9 is 3, but since it's negative, I stick on an I. What do I do with the 6?
Nothing, just
Leave it under the radical. And we still have that denominator of 3.
And you put the I because of the negative?
That's correct. The square root of a negative number is expressed using the imaginary unit I. Now, if we have a sum or difference, if we have a complex number divided by an integer, a complex number divided by an integer, the method I'll use to simplify, you can't just start canceling here. What you can do is you can split up. -6 divided by 3 plus 3i square roots of 6 divided by 3 and now we don't have addition or subtraction involved in any one of those fractions. It's just a number over a number. We can start canceling. -6 divided by 3 gives me a -2 plus, there's no addition or subtraction here. It's just multiplication and division, so we can cancel.
Where did you get the -2?
-6 divided by 3 is -2. Look in here. We have a common factor of 3. 3 divided by 3 leaves me 1i square roots of 6. Once I split it up over the addition, or if that would have been a subtraction, once I split it up into individual fractions, I can cancel common factors.
Make sure you don't start canceling a number under a square root with the number not under a square root.
And we mentioned that the last time. You can't cancel something that's under a square root something that's not under a square root. It was one of the last problems there in the homework.
Let me type this in. Okay, click in here to get the toolbar. -2 plus, I'm just going to hit lowercase I. Sometimes students say, wait, there's no I here. What do I do? Just hit the lowercase I, or hit more, and they'll show us I.
There should never be a time you need to hit more on the toolbar.
Yeah, if you find yourself hitting more, well, okay.
That's not necessary.
I think 3, 4, and 5 are all the same type of problem.
Any questions there?
Let me go back. Any questions? Y'all caught up?
Number 4. Eight minus the square root of -72 all divided by 2.
Looking to make sure you didn't miscopy it here.
You'd be surprised. Students coming by, they can't get the right answer. First thing I always do, well, let's log on and make sure you didn't miscopy the problem. And 9 times out of 10, guess what? Miscopied problem.
I mean, that happens to everyone. I mean,
yeah, but
us, I mean, it's
if I
not
miscopy a problem, it is next impossible for me to spot the error. So if y'all notice me miscopying a problem, you better tell me, okay? So,
but, okay.
fortunately, Tony's here watching, and I know when Tony's writing, I'm watching what he's doing, so, but still, things slip by us. The square root of -72. Let me ask you this. Are we going to have an I in our answer? Yes, because that number there is negative. Is 72 a perfect square? No. What's the largest perfect square that divides evenly into 72? No, there's a bigger one than 9. 36. 36 is the biggest one. If you try to use 9, you'd get 9 times 8. 8's divisible by 4. That's why you can't use 9. Remember, the number that's under the square root can't be divisible by any other perfect square. If you use 9 times 8, 8 is divisible by 4. So use the biggest number that divides evenly into 72, and that's 32. So let's 36. So here's my thought process. That's a -36 times a -2.
No, times 2.
I mean times 2, you're right. Oh. 8 minus...
So why don't you write it all in red?
I'm going to. The square root of -36. The square root of 36 is, but since it's a negative, what do I do? Okay. What do I do with this? Nothing, just bring it down.
Bring it over.
Bring it over, down, whatever.
Now
If you have a sum or difference on top and just a single number on the bottom, the best way to simplify, don't just start canceling. Split it up.
Marks, yeah.
Oh yeah, you're and those little marks in there.
Marks to show you.
8 over 2 and 6i squared to 2 over 2. So we have 8 over 2. Let's make sure you're following. This black minus right there, that's the minus I'm writing there. Then I have 6i squared to 2 all over 2. Now we can cancel and simplify each fraction individually. 8 divided by 2 gives me minus. Okay.
Perfect. Did y'all hear that?
You can't cancel those things because that 2's under the square root and that isn't. 2 goes into 6 3 times, and I heard them say 3i square root of 2.
Well, wait a minute, Tim. I see 4 minus 3. Can I write that as a 1?
No, I can't.
I cannot.
think of that I as a variable. You can't add or subtract something with a variable with something that doesn't have that variable.
And even, you can't, what we saw the other day with square roots.
Mm-hmm.
You couldn't, because there's not a square root on the 4. So leave it as 4 minus 3i square root of 2. Ready for me to punch it in?
Any question on my logic here? Well, go ahead and punch it in. And then
They'll feel better knowing if it's right. 3i. Let's see, where's that square? Oh, right there. Square root of 2.
Okay, switch back to my work here. You know, as I look at that, it looks so messy. It seems so neat as I'm writing it down, but... Okay. Any questions there?
I think that the 5th problem...
It's going to be it's similar to this, but it's going to be messier.
Yeah, the numbers are a little messier.
The final answer is a little messy.
Oh, and by the way, I should mention this. Pearson usually has a view and example option down here where they sort of walk you through.
Notice the example is extremely similar to the example of what we're doing.
And now, if you used to help me solve it, it'll step you through this particular problem, but then and guide you through to get the answer. And then once it's through, guess what? It says, okay, now do one on your own, and gives you a whole new problem. Okay? So,
if you used to help me solve it, they're not going to give you credit for the homework problem.
Until they change the numbers and give you a new one to do. Oh, by the way, notice how up here we've done, it says 7 of 18 points because
the media.
There were 3 videos. It's counting those 3 videos and then the 5 problems. The 15 problems. That's where it's getting 18. The Pearson grade book will automatically update as you do these problems. The Canvas grade book is a little slower to update, but if it hasn't updated within 30 minutes, don't worry about it. Just tell us later to check and make sure. Okay? Because
it is set to automatically sync when it's ready to sync. Okay? But
yeah. And so
once again, here's something else. Once again, if I wanted to know what is my course average at this moment, the Canvas gradebook is more accurate. The Pearson MyLab gradebook has some odd features that, for instance, once you take one quiz, Pearson will automatically assume, and I don't know why, but Pearson will assume that whatever you make on the first quiz is the same thing you're going to make on every quiz. So that's why I'm saying the Canvas gradebook is the one that's accurate.
At the end of the semester?
They'll be the same. At the end of the semester, they'll be the same. But if you're wondering, during the semester, the Canvas gradebook is the one that's more accurate.
Now, did you write this problem down?
No, I forgot what I was doing. I thought I'd just stand up here and talk some. Okay. All over 60. Negative 20 plus the square root of negative 50, all over 60.
Well, are we going to have an I in the answer?
Yeah, we're going to have an I because of what?
There's a
negative under the square root.
Not this negative. Not the negative in front of the 20. It's the negative under the square root that gives you an I.
Okay.
Oh, let me flip over so you can start writing it out. Move that up.
I'm going to there.
Negative 5 and 2?
I think you're right about that. I was about to ask, is 50 a perfect square? And y'all were going to say
no.
No. And what's the biggest perfect square that divides evenly into 50? And you said 25. So you're thinking of that as, here's how you're thinking of it. Negative 25 times 2. How we're going to denote the square root of negative 25. 5i, I agree. The square root of 25 is 5. Since it's negative, we stick on that I. What do we do with this? Just bring it down as the square root of 2. And then it's still over 60. If you have a sum or difference divided by an integer, you split up negative 20 over, oh, that's right.
The universal marks.
The universal marks for splitting up, there and there. That's
Don't
negative
panic. I think this one's
20.
going to have a fraction in your answer. Maybe 2 fractions.
Maybe 2, that's right. Okay. Negative 20 divided by 60. We can cancel a 20 above and below. 20 divided by 20 is 1. 60 divided by 20 is 3. So we have a negative 1/3 plus, what can we cancel here? Okay, 5 will go into 60 12 times. 60 divided by 5 is 12. Hey, can we cancel a 2 here? No, because you can't cancel the number that's under the square root with the number that's not under the square root. So we have I square root to 2 all over 12.
Now that's going to be a little bit messier to type in. Any questions on that?
So you just, I got lost kind
Oh,
of.
okay.
Of like the bigger number underneath.
If the bigger number's on the bottom, it's a fraction. Okay?
My weakness.
Oh, okay.
5 divided by 5 gave me 1 I square root of 2. 60 divided by 5 gave me 12. I divided both of those numbers by 5, just like I divided both of these numbers by 20. 20 divided by 20 gave me the 1. 60 divided by 20 gave me 3.
Okay, 20 over 60 is not 3. It's 1 over 3.
And it's okay to leave it as a fraction like that?
Oh, yeah.
Yes.
Okay.
In algebra, you generally leave stuff as fractions, not as decimal numbers. Let me see. So to type this in.
I recall typing fractions the last time.
Oh, yeah, we did. Okay, but I don't know if it was anything this. Okay,
No.
so it's a negative. And I'll hit the little fraction hot button, 1/3.
And then plus,
Don't do that. What's wrong? That plus shouldn't be in the bottom. Shoulda. So do what my brother said. Either hit the right arrow or click over here. I'll just hit right arrow to get out of that flashing denominator. Plus another fraction. I square root of 12. No, square root of 2. All over 12. Check it. Any questions on that? This is a messy problem, no messy manipulation. Any questions how we did that? Notice how algebra builds on itself. Okay, the last time, on Wednesday, we learned how to simplify things like positive square root of 50. Today we've
square
learned...
root of positive 50.
yeah, the square root of positive 50. Today we've learned how to simplify the square root of negative 50. How do we simplify this fraction? Well, we start off by simplifying that square root of negative 50. Okay? It's the way this stuff builds on itself. Let me see.
Let's see what number 6 is.
So a complex number is just a real number together with an imaginary number. On problem number 6, it says add and simplify. What we're doing here in words is we're adding two complex numbers. The negative 5 plus 7i, that's a complex number. And then the 9 plus 5i is a complex number. We have a real number together with an imaginary number. A real number together with an imaginary number.
I need to write something down first.
Okay. Adding and subtracting complex numbers.
Remember I said the algebra involving those i's is very similar to the algebra involving just variables. So for adding and subtracting complex numbers, all you're doing is combining like terms. We're just combining like terms. Think of the i's as if they were letters. You can't add something that has
I is a letter.
No, I mean as if it were a variable.
Variable like that.
You can't add something without an x to something that has the variable x. So I didn't write down the problem.
I know. So now we will go back and write down that problem.
This is number 6. There's the complex number -5 plus 7i
Added to
to the complex number 9 plus 5i. Oh. I may have done something. I should switch back. There, that's good.
Well, let me make sure it's focused correctly because you lowered it, right?
Yeah.
Okay, that's
Does that look focused? Looks focused to me. Okay.
Okay, so combine like terms. I can't add the -5 and the 7.
You know what to do when you're combining like terms. The first thing you do when you see those parentheses, you look and ask yourself, is there anything there in front to distribute through? I don't see a number in front of this first set of parentheses, so it's like multiplying by a +1. So this is an unnecessary set of parentheses. You just drop them. -5 plus 7i. The second set of parentheses, I don't see anything in front there. That's just like a +1, a +1. Distributing through a +1, would that change anything? No, it's another unnecessary set of parentheses. So just drop them. And then you combine like terms. You combine the constant terms, the things that don't have a letter. -5 plus 9, that gives me a, okay. And then combine the things that have the letters, the like terms. 7i plus 5i. You keep the I part, you add or subtract the coefficients. 7 plus 5 is 12i. So we have...
Be careful, don't add the 4 and 12. It's tempting to, but they're not like terms.
So 4 plus 12i.
So to add complex numbers, combine like terms. Sometimes students will say, well, wait, I could have done that problem without... Oh, wait, what did I do wrong?
The I.
Oh, I didn't put my I, huh? Okay. But your goal, if you can do this faster or in fewer steps, as long as you're not using a app like Photomath, then by all means do it. Like that step where he removed the parentheses. I think a lot of you could have just, okay, -5 plus 9, 4, 7i plus 5i, 12i. I think you could do it without showing that step of removing the parentheses, but on this next one, when you're subtracting complex numbers, what am I going to have to do with those minus signs in front of the parentheses? Yeah, you've got to distribute them. There's no way around writing out, removing those parentheses. So, 5 plus 9. write it down right? Mm-hmm.
Well, the first set of parentheses, there's nothing in front to distribute, so it's another unnecessary set of parentheses. I'm just going to drop them and write my 3 minus 4i. Second set of parentheses has a minus in front. Distributing through a minus, what's going to happen to the signs inside these parentheses? Okay, so that's like a positive 5 and a plus 5i. So that's going to become a minus 5 or a negative 5 and a minus 5i. Distribute the negative through here. What are we going to get? Okay, it's going to become a positive 6 and a minus I. I agree.
You did it to the universal signs for distribute, Tim. I'm all about these universal symbols.
That he made up himself, I might
But I think anywhere that's, using the Hindu-Arabic number system would write that to show distribute. Okay. Do y'all know that's our number system, the Hindu-Arabic number system? Yes? Okay, good.
Okay, now we can combine like terms. Combine all the things that don't have eyes, and then combine all the things that do have eyes. Let's combine the things that don't have eyes. 3 minus 5 is negative 2 plus 6 gives me 4. Okay, so my real part of the number is 4. Now, negative 4i minus 5i, that gives me negative 9i minus, I don't see a coefficient here. What do we assume it is? Okay, so you said that's a negative 9i minus 1i. Negative 9 minus 1 gives me negative 10i.
Negative 4i plus a negative 5i plus a negative 1i is a negative 10i. Do I subtract the 4 and 6? Excuse me, the 4 and 10?
No.
No. Am I beating a dead horse there? I'm not going to mention it again. When you have these two numbers like that, you can't subtract them or add them.
Any questions there?
This is called subtracting complex numbers. It sounds harder than it is.
It's just combining. If we, in Math 3, if you had taken Math 371, you would go through combining like terms, but the i's would just be letters, and that's exactly what you would do. If you had a 3 minus 4x minus a 5 plus 5x minus a negative 6 plus x, that's exactly what you would do to combine like terms. Any questions there? So we've added and subtracted complex numbers. Now we're going to divide.
No, we're going to
divide. Multiply complex numbers. Okay, we're going to multiply complex numbers. Put it on my paper for a minute.
Okay. Last time we got a rule involving square roots. Do you want to find it in there?
No.
I just love this ability to flip back over what we did the last time.
Let's see. Ah, here it is. Do I remember this rule? The square root of a times the square root of a, that's the same thing as the square root of a squared, which just reduces to a. Do y'all remember that? I would have mentioned that the square and the square root just undid the impact of each other. Square root of 2 times the square root of 2 became a square root of 4, which reduced to 2. Y'all remember that? Yes? Okay. So, remember I said that the, I should probably write that down. I'm going to say, recall the square root of a quantity squared just reduces to a. Recall that from the last time. And remember I said that the square root of -1 is denoted using a lowercase letter I. Suppose we squared both sides of this equation. I said this is the formal definition of the imaginary unit. Suppose we square both sides. On the right side we have I square. So there's I square. What's the left side going to reduce to? What's going to happen when we square that square root there? So we're just going to, okay, the square and the square root are disappearing, so we're just left with the -1.
Why not write a star?
I'm going to box that in, and I'm going to put one of those big red stars. I'm going to write it the other way around. Equality is commutative, okay? A equals B is the same thing as B equals A, so I'm going to write this rule with the I square on the left side. I square is equal to the real number -1. As we go through multiplying, think about multiplying variable expressions. You're picking up x times x, and oh, my battery's dead, it looks like. I'm surprised it's still working after it worked the last time, you know, and it seems like these 2 batteries will last 1 class period, and that's about it. So I'll keep on trying to use it until it's completely dead. Think about multiplying x times x. That becomes x squared. So every time you're multiplying and you're picking up powers of I, you need to reduce those powers of I using the fact that I squared is equal to -1. You can have an I in your answer. But because I squared is equal to -1, you should never have powers of I in your final answer. I'll say no powers of I in your final answers. Tony, can you think of a better way to say that?
No.
No? Okay.
I's. Real numbers and
you can
I's.
only have I's. You can have real numbers.
BI.
You can have a real number. You can have an I. You can't have an I squared. You can't have an I cubed. Only I. Now, multiplication of complex numbers looks an awful lot like just multiplication of variable expressions.
Does the word foil mean anything to you? Hopefully it does. Here's number 8.
Well, you told them what we're going to do, Tony.
I
I would have said, suppose those I's were X's. What would we do to perform that multiplication? And someone would have said foil.
Oh, well.
Yeah. Tony, you want to take over?
Okay.
Tony's better at talking loud.
Now, 7 plus 2i times 5 minus 6i. You didn't miscopy it?
Oh, wait. Let me see.
But notice how the instructions say multiply. Sometimes students say, well, wait, how do I distinguish the difference? Years ago, I mean literally years ago, in 1992, I was at Bamboo Garden. And a waiter came up to me and Tim. We were both there, and he said, do you teach math at Del Mar? And I was, yeah, this was before most of y'all were born. And I was like, well, yeah. And he was like, I'm taking math at, and I, oh, wow, okay. How's it going? Well, it's going okay, except my teacher's an idiot. At that point, I immediately, okay, let's end this conversation and just move on past this. And oh, I'm so sorry to hear that. Yeah, you won't believe what he tells us to do. He says we got to study the instructions. That idiot. That was wait, no, actually, that's sort of important for you to pay attention to the instructions. Like this one, it says multiply. How do we multiply? You foil. Throughout the semester, as we go through stuff, we'll be discussing.
If it's a sum of difference times a sum of difference, if it's,
Yeah, I know.
Binomial times binomial. That's
Binomial times binomial is FOIL, yes. But you do sort of have to pay attention to those instructions. Here we're multiplying. We're not adding or subtracting. So, first, outer, inner, last. Okay, I'm starting to FOIL. The 7 times 5, 35. First, outer, 7 times negative 6. Is that going to be negative 42i?
You sound like you have doubt, that you're not sure that it's a negative 42.
I do sound like I have doubt. Why? When I talk, I sound like I have doubt a lot of times, because when you hear someone expressing doubt, your brain, most people's brain, will automatically try to figure out, is that the right answer? So, the 2i times 5, what's that going to be? 10i. Ooh. And then the 2i times a negative 6i. Okay, that's going to be the positive 2 times negative 6. That's a negative 12. And I should have done what my brother did and just write it underneath here. I squared. Every time you see an I squared, you have to replace that with a negative 1. What's that going to do over here to this negative 12i squared? If I put a negative 1 right here, negative 12 times negative 1 is positive 12. So in place of this minus 12i squared, I now just have a plus 12.
Scratch out that.
The I squares just change the sign of the number in front of it. See, all of this is gone now, and we just have a plus 12. Now can we combine the like terms? What can I combine with the 35? 35 plus 12 is 47, Negative 42i plus 10i is, it's at negative 42 plus 10. I'm thinking it's going to be,
at the beginning.
Oh, you did?
Minus 32.
Oh, okay. Minus 32, negative 42 plus 10. So we have 47 minus 32i. Yep.
Any questions? It looks like a binomial times a binomial. You FOIL as if it were variable expressions. The only difference, once you pick up that I square, that's negative 1 times a negative 12, it becomes a positive 12. Question?
You just kind of put 12 out.
Okay. If we had had more room here, I would have shown negative 12 times negative 1. That I square is a negative 1. Negative 12 times negative 1 gives us a positive 12. We have plenty more examples to do here, though. So let's type in this one. 47 minus 32i.
Number 9 is the exact same type of problem, but it doesn't look it. Negative 6 plus 9i all squared. Well, the most basic form of problem solving is if you know how to do one type of problem and you're confronted with a new one, try to make it look like the one you know how to do. We know how to
do
that. You FOIL it out. If there's 2 sets of parentheses, we know how to do it. What am I trying to say poorly we need to do on this one? Yeah,
Okay.
just write it down twice. Squaring means times itself. So let's write down -6 plus 9i times itself. And now we'll FOIL out.
Don't do it in this little space here, Tony. Do it down here. Write it out big like I do.
-6 times -6, 36. Then a -6 times a positive 9i. That's going to be -54i. Is that what I heard?
Inner. First outer. Now we're doing inner. What's that going to give us?
9i times a -6. That's another -54i. And look what we're about to get. 9i times 9i. 9 times 9.
So it would just be 81. Cancel all that out.
81. And we have that I times I squared.
What's that plus 81i squared about to become?
-81. Did y'all hear that? If I replace this I squared here. If I replace the I squared with the -1, this positive 81 times -1, that's just going to be a -81. So all of this here, the 81I squared is just a -81.
Yeah, replace all of that with -81. There.
Oh. Okay. It looks sort of messy.
What can we combine? Okay, so the
36.
things without the I. 36 minus 81.
36 minus 81, that's going to be negative what? 45? Uh-huh. Now, be careful. Sometimes students will say they cancel out. No, they don't. Negative 54i minus 54i. Negative plus negative is negative, what is it going to be? 108i. So we have a negative 45 minus 108i.
Any questions there? If you have a complex number squared, you write it twice, FOIL it out. Don't forget, I squared is equal to -1.
So all that does is change this green plus in front of the 81 to a negative 81. Okay?
Negative 45 minus 108i. Any questions there? Now this isn't going to be a FOIL problem. If we were thinking of the I as a variable, -5 plus 4i, that's a binomial. But here there's not two terms. That's just a monomial. A monomial times a binomial. We're not going to FOIL. What are we going to have to do here?
It's a D word.
Distribute, I agree. Well, did you make sure we copied it right?
Oh. Did I copy it right? -4 times -5 plus 4i. Okay.
Yeah, okay.
So just distribute. -4i times a -5. What's that going to give us?
29.
Okay, so we have 20i.
Negative times negative gives me positive. That's why we got that positive 20i. What else?
Okay, so it's going to be a -16. I times I is I squared. Oh, I like this because I have all that space above the -16i squared. If I replace this I squared with -1, Negative 16 times negative 1 is, yeah, it's just going to be a positive 16. Mark out all of that. That's all gone. And in its place, we have that plus 16. And the instructions, they generally want the thing that doesn't have the, that has no I first. Instead of writing 20i plus 16, we should write the 16 first, and then the I term at the end. But I can't help it, I'm going to say it. Don't combine the 16 and the 20. Earlier I said I wouldn't say that again, but no. It just stays as 16 plus 20i. Y'all see why we're writing it like that rather than 20i plus 16? Look at the answer, Tim. Look at the instructions. I believe it says write in the form A plus BI.
No. Oh, yes, it does.
Yes, it does. It doesn't say write in the form BI plus A. Okay, the I term should be at the end. So, is it clear why I wrote it like this? Okay. I wrote that.
Depending on who the programmer is for Pearson was programming this problem, they might take 20i plus 16, but they may not. So, in general, if you have a complex number, a real number and imaginary number, put the real number first and then the imaginary number. That's just standard practice. Just like my car. When I'm driving down the street, I can move over on the left-hand side. My car works just fine on the left-hand lanes. But it's standard practice to drive on the right-hand lane, okay? So it's standard practice to put that thing without the I first. And that's important. You don't want to take a chance typing in 20i plus 16 on a test, and then it's counted wrong, okay? So 16 plus 20i. How do you have 5 more problems? Do we keep going or do we take a break?
Keep going?
Okay.
If you
need to step out, you feel free to step out. As a matter of fact, I'm about to step out for a second, okay? I was drinking too much iced tea before class.
Negative 8 plus 6i. And 3 minus 9i. Oh, okay, negative 8i plus 6, negative 8 plus 6i times 3 minus 9i. Am I going to have to FOIL this one? Yeah, it's binomial times binomial. So, let's get started. First, it's a negative 24, negative 8 times 3. Now, what about outer? Negative 8 times negative 9i, that's going to be, yeah, negative times negative is positive, 72i. So first outer, inner, the 6i times 3 is, oops, is that a 18i? 6i times 3. First inner, right, first outer, inner, last. What about positive 6i times a negative 9i? That's going to be a negative 54i squared. I'm about to do this, making very few, showing very few steps. Replace the I squared with the negative 1. So negative 54 times negative 1 is going to become a positive 54. And I'll mark all of that out. All the I squared does is change the sign in front of the 54. Okay? Now let's see. What can I combine with the negative 24? Yeah, negative 24 plus 54, 30. Now combining the I terms, 72i plus 18i instead of 90i? And I just can't help it. I've got to say it. Don't add the 30 and 90. Those aren't like terms. Any questions? Let's see. Number 12. Did it take over from it? We should have made that bigger. It's hard to see it. Oh. Yeah, I think it'll still do. Yeah. Tried to make it a little bigger. Oh, I think it was fine the way it was. We have the complex number 8 plus 3i, and it's being multiplied by the complex number 8 minus 3i. Are we going to FOIL on this one?
Yes.
Which over? So here we go. First, not a trick question. 8 times 8, 64. Outer. 8 times negative 3i. Negative 24i, I agree. Inner. Okay, a positive 3 times a positive 8, that's a positive 24i. Last. Okay, positive 3i times a negative 3i, that's a negative 9, and I times I is I squared. As soon as I pick up that I square, I get rid of that. I square is equal to what number? So negative 1 times negative 9, what's this last term going to become? A positive 9. I agree. So let's combine the numbers that don't have i's. 64 plus 9 gives me 73. What's about to happen? This is the first time this has happened. Okay. Negative 24 plus 24. This is not like what happened over here. It was a negative 54i minus 54i. That gave us a negative 108i. There the signs were the same when we were squaring that binomial. Here the signs are the opposite. Negative 24 plus 24, that's 0. You have 0 i's in your final answer. Your final answer is just 73.
Oh, wow.
The i's subtract out.
It's a real number.
That's the first time this has happened. We multiplied two different... Oh. Hold on.
Yeah, I did make you get it too big.
I know.
Hey, wait, we should have done this.
Oh, well, don't be playing around.
Okay, I forgot what was the answer. 73.
Oh. Any questions there? There. Switch back to my piece of paper. Why did that happen? Why did these I terms subtract out? That's a very important concept here.
What was unique about this problem and not any of the others? Perfect.
Notice you have the same in the multiplication. You have the same terms. The only difference is the sign connecting them. You had one positive and one negative. Complex numbers in that form are called conjugates. A plus bi and a minus bi are called conjugates. Okay.
So at this point, we've added complex numbers, we've multiplied we've subtracted complex numbers, we multiplied them.
We're getting ready to divide. This concept involving conjugates is going to be important for division of complex numbers.
If you have two complex numbers with the exact same thing, except the middle signs are different,
then their product will not contain an I. I think I'm going to write a note there. I'm going to say the product of conjugates, the product is what you get when you multiply two numbers. The product of conjugates does not contain an I.
in other words, it's a real number.
When dividing complex numbers, division of complex numbers.
I think that what you're about to write makes more sense if they see the problem written out. So
I just want to make it. We've already divided some complex numbers. Do y'all remember problems 3, 4, and 5? We've already divided problems.
I know that.
This goes back to what Tony's always saying about make the problem look like something you know how to do. We've divided complex numbers right there. We have the I, but the divisor, the denominator, is just an integer. If we don't have an I in the denominator, we know what to do. We split up and reduce the fractions individually.
What I wanted to show them was that when we talk about division, we mean written like a fraction, not long division bars, okay? Y'all know what I mean by long division bars? 2 plus 4i divided by 1 plus I, not that. Here, by division of complex numbers, we mean fractions. What he was saying is, we know how to do it if there's just a single number down here, a real number.
Not an I. So our goal, switch back to the paper. Our goal when dividing complex numbers is to get no I in the denominator.
And then separate.
You want to get no I in the denominator, and once you've done that, you can separate the fractions and reduce them like problems 3, 4, and 5. Once you have no I in the denominator, split up the fractions and reduce like problems 3, 4, and 5. That's why we had 3 problems like that, where it's a complex number with an I on top and an integer on the bottom. Your goal is to get rid of the I in the denominator and then split it up and reduce.
Now go ahead and write the sentence that relates division and conjugates to him.
In order to get rid of an I from a denominator, we know if we multiply 2 conjugates together, you're not going to have an I. Now, when working with the algebra of fractions, you know if you multiply the denominator by something, to maintain the equality, you got to multiply the numerator. So, to get rid of the I from the denominator, multiply to divide complex numbers, you're going to have to multiply above and below by the conjugate of the denominator.
Yeah, that's the sentence. That's important. This is what we'll be doing on these last 3 problems. 13, 14, 15.
If you multiply above and below by the conjugate of the denominator, the thing you get won't have an I left in the denominator. So at that point, it's like problems 3, 4, and 5, split them up. But if you're multiplying the denominator to maintain the equality, You're going to have to multiply the numerator too to illustrate. This is number 13. Oh, goodness. Okay. We have the complex number 2 plus 4i divided by the complex number 1 plus I. Make sure I didn't miscopy. 2 plus 4i. Okay. Let's switch it over to my paper.
I keep trying to
I
make
know,
it bigger,
just
but
stop.
it
Just switch it over there. Okay. Class is getting antsy. They want to go. What's the conjugate of the denominator? That's sort of funny because I'm always the one that keeps them late. Okay. What's the conjugate of 1 plus I? 1 minus I. Just change the sign that's there in the middle. So we're going to multiply above and below by 1 minus I. 1 minus I, 1 minus I.
Wait, why is it 1 minus I?
because the conjugate of the denominator is
Just the same terms, but with opposite signs.
conjugates have
The same terms, A and B, but opposite signs. Just like 8 plus 3i and 8 minus 3i.
Why are we multiplying by that?
Because the product won't have an I. We know how to divide. If there's no I in the denominator, you split up problems 3, 4, and 5. That means we're going to have to FOIL out twice. We're going to have to FOIL out the numerators and FOIL out the denominators. Let's FOIL out the numerator. 2 plus 4i times 1 minus I. First, I'm going to write small. First, 2 times 1. I couldn't hear you. 2, I agree. Outer, 2 times a negative 1i. Negative 2i. 4i times 1. Okay. What about last times last? Positive 4i times a negative 1i. That's a negative 4. 4 times a negative 1 is a negative 4. I times I is? Okay. And so, negative 4 times a negative 1, I agree, that's going to become a positive 4.
The I squared changes the sign of the number in front of the I squared. So just make it a plus 4. Negative 4 times negative 1. Positive 4.
1 plus I times 1 minus I. Let's FOIL that out. Keep in mind, everything containing what should cancel out. When we multiply 1 plus I times 1 minus I, what do we better not get? An I. The I's better subtract out. Here goes. First, 1. 1 times 1 is 1. Outer, 1 times a negative I. Negative 1i. Inner. Okay. Positive I times a positive 1. That's a positive 1i. The i's are subtracting out exactly the way we said that they should. What about positive I times a negative I? Positive 1 times negative 1, it's going to be a negative 1, I times I squared. Any questions on my logic there? On our logic there, since y'all are telling me what to write? I squared is negative 1. We're changing it, so what's this last term going to become?
a positive 1. Any questions on our logic there?
It looks messy, but it's about to simplify really nicely.
Let's simplify that denominator first. What's the only thing we have down here? The negative 1i plus 1i, that's gone. And we have, what did you say? I think I heard it. 1 plus 1, I agree. We have a denominator of 2. Any questions there? You say, well, that was my goal. No I in the denominator. You say that we have i's in the numerator. That's fine. You just can't have i's in the denominator. 2 plus 4. What have we got here in the numerator? 6, yes. Negative 2i plus 4i. What's that going to give me? That's a plus 2i. And then this reminds me of problems 3, 4, and 5. We have an I on top, but just an integer on the bottom. So what do?
Make those universal marks.
Oh, the universal marks. You're right. Oh. Those universal marks saying split up. 6 over 2 plus 2i over 2. Now, what did you say 6 over 2 is? Plus, what can we do here? Okay, the 2's cancel. 2 divided by 2, I agree, gives me just 1i.
Wow. So you're telling me that the complex number 2 plus 4i divided by 1 plus I is 3 plus I. Can I make up some rule to get that answer?
No.
Rather than having to do that conjugate stuff?
No.
No. Don't spend your time. Oh, wait, I can add the 2 and the 1 and... You know, people come up with all these strange rules. If there were an easier rule, I'd tell you. And we'd get out of here sooner. Okay? Change the symbol in the bottom and multiply above and below by that.
It's repeated foiling. Eventually, you're going to have a fraction where there's an I on top, just an integer on the bottom, split up.
That's like
those problems 3, 4, 5. Where were here? Here we had an I on top. Actually, 3, 4, and 5 were messier because we had radicals left there too. Once you get the I on top, you have an integer on the bottom, split them up, and cancel.
Oh, gosh. Let me punch that in and make sure we got the correct answer. 3 plus I. Check it. Here's another one, number 14. Oh, a little bit messier numbers, it looks like.
We have the complex number 9 plus I on top. And on bottom we have a negative 5 minus 2i. Plus I. Negative 5 minus 2i. Okay.
Oh, this is a really good example to illustrate how to find the conjugate of the denominator.
What's the conjugate of the denominator?
Look at the bottom. Do we change both of these negatives, or is it just one negative going to be changed? Just one. One in the middle.
The one that's in front of the I. Whatever, the real part stays the same. The conjugate of negative 5 minus 2i is negative 5 plus 2i. Good. So, now we're going to FOIL. We'll FOIL out the numerator and FOIL out the denominators. Let's FOIL out the numerator. First, 9 times negative 5.
Is this the most foiling y'all done in a long time? No? Oh, okay, good.
9 times the negative 5 is negative 45. That's first, outer, 9 times 2i. 18i. What about inner? 5, no. Positive I times a negative 5 gives me negative 5i. Last, positive 1i times a positive 2i. 2i squared, I agree. And let's simplify that 2i squared immediately. What's that going to give me? Okay, that's a positive 2 times a negative 1. So I agree that's going to become that negative 2 there. Now let's FOIL out the denominator. First, negative 5 times negative 5 is 25. Outer. Okay, negative 5 times a positive 2. I agree with the negative 10i. Inner. I agree. Negative 2 times a negative 5, that's a positive 10, and then you stick on the I, so a 10i. Last. I couldn't hear you. Sign. Wait, let's be careful. It's negative 2 times positive 2. That's a negative 4i squared. Oh, but when you change it, what's it going to become?
Yeah,
There's the positive 4. Okay. Any question on our logic there? Plus 4. Let's simplify the numerator now. What am I going to combine the negative 45 with? Negative 45 minus 2 is going to give me negative 47, okay. Let's combine the I terms. 18i minus 5i, I agree with the positive 13i. Now in the bottom, let's combine the things that don't have i's. 25 plus 4, that's 29. What's about to happen here? Is that an accident? Is that just a freak coincidence that those i's are canceling out? No, that's the whole point of what we're doing, getting rid of the I in the denominator. Negative 10 plus 10 gives me 0 i's. And now, we have an I on top. We just have an integer on the bottom. What do?
Draw the little mark.
I am.
Oh, okay.
We split them up. Okay. So we have negative 47 over 29 plus 13i over 29
Can you cancel anything in these? No?
47 and 29 are prime. 13 and 29 are prime. This is a pretty nice answer. We can't reduce any of those fractions.
Just leave it like that. Back in the olden days, Pearson would let you enter this answer. It won't anymore. Okay.
Back in the, seriously, before this year, well, not this year, before 2022, Pearson used to allow this answer. But with an update, it's been changed, so you've got to write it as two separate fractions, A plus BI.
So, let me see, how do I type this in? It's a negative, hit the fraction key, 47.
And then click down there below or use your down arrow to get to the denominator. What does he have to do now? Go over before he types that plus.
And another fraction bar. 13i. Go into the bottom and type 29.
Any questions there?
Oh, wow.
Okay.
May as well do the last one. It's the last one, so it has to be the hardest one. Isn't that general rule?
That might be a general rule, but I don't think that's true in this case.
Every once in a while.
Yeah, but not always.
Not
I don't think
always.
this one's the hardest one. It's just the real number 3 divided by 2 minus 5i. Well, don't let the fact that it looks a little different from the previous one. It's just a real number up here, but
We performed multiplication where it was just a 1 term times 2 terms. You're not going to have to FOIL up there, but we know how to do that.
what's the conjugate of the denominator?
2 plus 5i. I agree. Just change that middle sign.
You're not changing every sign.
Easier if I have the small
Huh?
one.
This one's easier.
Okay,
Yeah.
I was trying to
And it's not, usually if I say it's the last one, so it's got to be the hardest,
It is.
it isn't the hardest one. When that actually is the hardest, I don't say that.
No.
Okay, I'm never going to say, oh, this is a hard problem.
I do. Oh, well, I guess I shouldn't. Okay. We have 3. We need to multiply it by 2 plus 5i. We're not going to FOIL. What are we going to do? Distribute. Okay. I am. 3 times 2 gives me plus. Okay, 3 times 5i, that's a positive 15i. Now we're going to have to, are we going to have to FOIL on the bottom? Yes.
Oh, wow, yes.
Okay, first,
4.
outer. I couldn't hear you. Okay. When I say I can't hear you, it doesn't mean you're wrong and I'm giving you a chance to correct yourself. It means I can't hear you. Loud music from a very young age, okay? And so, when I say I can't hear you, I just can't hear you.
What, Tim?
I think my hearing might be a little worse than yours, though. Okay. Enter negative 10i.
And he's just trying to slow down because we're going to finish early. So don't let him trick you into doing that. Okay?
Last, negative 5i times a positive 5i gives me. Okay, good. And what am I going to do with this last term here? Okay, negative 25 times a negative 1, that's becoming a plus 25. So,
Why not mark out those 10 eyes also?
oh yeah, what's going to happen here? Is that an accident? Is it just a freak coincidence they're subtracting out? No, that's why we're doing this. We're making sure there's no i's left in the denominator. So what have we got down here on the bottom? 4 plus 25, I agree with 29.
Oh, wow.
And we still have a 6 plus 15i on top.
I'm saying wow because number 14 had a 29.
That's just a
Great
coincidence. And what do we do now to get in the form a plus or minus bi? Split it up. Okay. So we have 6 over 29 plus, we have 15i over 29. Can we reduce either of those fractions?
29's prime.
29's prime. Now, for a second, I was thinking 27, thinking we could cancel 3's, but that's 29. 29's prime. Can't do anything. There.
Let me
That looks like it. Wait, come back over here. Go back to my paper. That's not a 2.9.
Oh, it does look like a point
just-
there. It's just a
No,
29.
I was
Is it-
saying the answer before that was what I came up with. I didn't realize you had to break it down even further than that.
Oh, yeah, it used to let you stop there.
It used to, but I
last-
think they count it wrong now. You have to split
Write
up.
it in. I'm curious.
Let's see, okay.
Let's see.
I'm just curious.
Six-
So it'd be 6 plus 59.
But even if they do take it,
Some of them don't.
some of
because
them
the last
don't,
time-
depending on who the program or who the
I
huge.
get it, but,
No,
they're
You have to
not.
break it
You
down.
see,
Okay.
if you don't break it down,
If it's two terms with a compound with a complex number, you've got to put the thing without the I plus the thing with the I. Plus
15I
over 29.
to 29. Oh. Okay. Any questions?
Now
At this
with
point, we have 100. Give it a few minutes, and Canvas will show 100 on your homework.
on my homework or your homework, whoever's account this is,
Yeah, but,
not on their homework. They got to go do their homework. Okay,
Now,
let's stop it. We'll upload this
any
video.
questions before we see? Look here. You click on the grade book on Pearson. This is now Pearson. We made 100 on our first homework. We made 100 on the second. No reason why y'all shouldn't be doing the same. You can rework it until you get it right. And if you say, well, I don't want to bother reworking until I